All right, in this video, I want to do the curve sketching algorithm for this question over here. So the first thing I'm going to do is I'm going to derive this equation, bring the exponent down and subtract the exponent by 1. Now multiply the exponent with the front, subtract the exponent by 1, and then the constant there just disappears. Then I'll make the derivation equal to 0 to find my critical points. To solve this, I need to factor it. I can common factor out a 3x, left with x plus 2. So I know that my critical points are x equals to 0 and x equals to minus 2. The next thing I'm going to do is I'm going to put my critical points on a number line so I can classify them as maximums or minimums. Put them from the lowest to the highest. So I'll first test this interval over here. I can pick any value less than -2. I'll pick -3 and I'll sub that into my derived equation right there. I'll do it in my calculator. I get +9, so I know that if it's a positive value, it's an increasing interval. So draw an arrow going upwards from left to right. Then I'll pick a value between there. Just pick -1. And again, I'll do this in my calculator. Could do it on paper as well, but I'm just going to rely on my calculator for this video. Get -3, since the negative value, it's a decreasing interval over there. So I'll draw an arrow going downwards. And last, I'll test +1. And again, I get +9, which means it's an increasing interval right there. So next, I will classify my critical points. Over here, if I look at -2 and I look at that, you can tell that that shape right there is a maximum. I'm going to have a maximum and the x value is -2. To find the y value, take the x value and sub it back into the original equation in the question. Do not sub in the derived equation. So again, I'll do this in my calculator. I just get a y value of 0. So that is my local maximum right there. If I connect these two lines over here, I can tell this is a minimum. So I have a minimum. The x value is 0. To find the y value, again, I'll sub in the original equation. That will just give me -4. Once I've classified my critical points, I'll do my intervals of increase and decrease. So if I look over here, this is an interval of increase from -infinity till -2, and then I have another interval of increase here from 0 to +infinity. Only have one interval of decrease there, which is from -2 till 0. Once I've completed the intervals of increase and decrease, I'll go back to my derived equation over there and I will derive it for a second time. If I derive that again, I will get 6x plus 6. Then I'll make the derivation equal to 0 to solve for my inflection point. Move the 6 to the other side. This is linear now. And then divide both sides by 6. I get -x equals to 1. So this is an inflection point right there. The x value is -1, and to find the y value, I've got to sub that in back into the original equation. So again, I will do that in my calculator and get a y value of -2. So that is my inflection point. Once I get my inflection point, I'll do a number line to find my intervals of concave up and concave down. I'll just put my inflection point on my number line, and then I'll pick a value less than this. So I'll do F double prime, or I guess Y double prime, this case of -2. So I'll sub in -2 in my second derived equation, and I will get -6 if I do that. If you get a negative value, it means it's concave down. Then I'll sub a value greater than -1, so I'll do Y double prime of 0. Just +6, positive value means it's concave up. So my intervals of concave up are from -1 to infinity, and my intervals of concave down are from -infinity to -1. The last thing I'll do in this question is I will sketch this out. Sketching it out is pretty easy. All you want to do is put your max. So we have a max at -2 and 0, a min at 0 and -4. And then I have an inflection point at -1, -2. Don't even have to worry about your intervals of increase, decrease, concave up, concave down here, because if I just draw this as a maximum, that whole range is going to be concave down. And then here at the inflection point, it's going to switch concave up, and this is a minimum right there. And that's what the graph is going to look like. For this question, the last thing I'll do is I'll label all the points. And I label the points after so that I don't overlap my points with the actual graph itself. So this is just -2 over there. That's just -4. Since they're x and y intercepts, I don't need to label the other values. And this is my inflection point, which is -1 and -2. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.